In this lesson, we're talking about section 2.6 from our Apex Calculus book, and this is on implicit differentiation. And the biggest thing that I want to share is that implicit differentiation is really just the chain rule. So when we are taking derivatives, they are acting like taking the derivative is a function itself. So if y equals f at x, taking the derivative of both sides of the equal sign results in dy dx equals f prime of x. And the reason that we have implicit differentiation is because derivatives can be applied even when we don't have y equals something, when we don't get to the point where y equals some function of x. So let's look at an example. Suppose we have x squared plus y squared equals 1. The graph of this equation is a unit circle centered at 0, 0, has the radius of 1, and we want to find the slope of the tangent line at the point 1/2 square root of 3 over 2. Well, let's pretend that we can't solve for y in this situation. So we're just going to take the derivative of both sides of the equal sign. The derivative of x squared plus y squared is the derivative of 1. And on the left-hand side, I've got a sum, so the derivative of x squared plus the derivative of y squared equals the derivative of 1. That's our sum rule. We already know the derivative of x squared is 2x, and the derivative of y squared is 2y dy dx. Put a pin in that for a moment, and then that equals the derivative of 1, and the derivative of a constant equals 0. So going back to the derivative of y squared, why does that equal 2 times y times dy dx? Well, it's called implicit differentiation, but remember, implicit differentiation is really just the chain rule. And so, dy dx, that went ahead a little bit too far. I wanted to talk about this thing right there. I said it was the chain rule. Outside equals x squared, inside equals y, and the derivative of the outside is 2x. The derivative of the inside, the derivative of y, equals dy dx. We've been doing this for several weeks now. So that's why the derivative of y squared is 2y, because that's the derivative of the outside composed with the inside multiplied by the derivative of the inside. And then solving for dy dx, we get dy dx equals negative x over y, and that tells us that the slope of that tangent line is negative 1/2 divided by the square root of 3 over 2, which just simplifies to negative 1 over the square root of 3. Let's do another example. Find dy dx for the equation natural log of y plus x squared equals e to the x. Taking the derivative of both sides of the equal sign, we get the derivative of natural log of y plus x squared equals the derivative of e to the x. Well, the derivative of the natural log of y plus the derivative of x squared, which is equal to 2x, equals the derivative of e to the x, which is equal to e to the x. And what is the derivative of the natural log of y? Well, we're going to use the chain rule. Implicit differentiation is just the chain rule. So my outside function looks like natural log of x. My inside function is just y. And the derivative of natural log of x is 1 over x. The derivative of y is dy dx. And so the derivative of the natural log of y is 1 over y times dy dx. because it's the derivative of the outside composed with the inside multiplied by the derivative of the inside. So now we have, going back to our original problem, 1 over y dy dx plus 2x equals e to the x. Subtracting 2x from both sides, we get 1 over y times dy dx equals e to the x minus 2x. So dy dx equals y times e to the x minus 2x. And so we just repeat this process over and over and over. Again, practice makes perfect. Remember, the implicit differentiation is really just the chain rule, so we're not doing anything that's new and groundbreaking.